So ninth standard, just now I sent a video, pressure inside fluids. How do fluids exert a pressure? So we'll just derive the formula for it. So this one is a derivation of your formula. So consider a trough which is consisting of liquid. So you all know these are liquid layers. I told you here, I mean in your video you have seen each the liquids has to be divided into the layer. So the bottommost layer will be having the entire weight of the layers which is above it. Okay, so here consider there are going to be 10 layers. So this 10th layer will hold the weight of the 9 layers which is above it. So now let us calculate the pressure formula. So what is your pressure formula? So here you might be seeing something different. Miss, just before this video we saw pressure is equal to thrust acting perpendicularly divided by area. That is all we saw, but here you have given some different symbols. So let us see how it is working on. So now you consider a vessel. I'm just going to consider one particular area, I mean a particular surface over here. So this is your particular surface PQRS. Now measure the height and how much area it is going to occupy. That is what you have to measure it. Okay, the height and the area. So what is your thrust formula? Thrust is nothing but the force. Yes or no? You remember thrust is nothing but the force which is acting in a perpendicular direction. Now recollect, what is your force formula? Yeah, what is your force formula? You would have studied in your Newton's laws. The same formula we are going to apply here. There is no much difference. The same. Okay, if you have recollected, the formula is mass into acceleration. So here what acceleration will be acting on it? It is your acceleration due to gravity. So here we'll be using G. So mass into G. But I don't know what mass is going to act on it. It's just a section I'm going to take, but I cannot divide it and find what mass it is. So I can use in another formula for mass. Is there any other formula for mass? Think about it. See, I know the height, I know the area it is occupying, I know acceleration due to gravity is happening, but apart from that, whatever kind of liquid you take, the liquid will have some of an intrinsic property. It will has its own self characters. If you take a water and an oil, what is the difference you will tell immediately for both of them? You take a water and an oil, what you will tell first of all? Yes, the oil is different in its density comparing to the water. So in order to measure the mass, the thing which I'm going to use here is my density. So think about the formula of density which you studied in your 8th standard. What is your density formula? Mass divided by volume. So obviously I know my volume. If I'm going to take 1 liter of water or 2 liter of water in the trough, I know my volume here automatically. And the next one, I know the density of my water. Yes, you are right. Think about the density of water, it is 1000. So I know the density of water, I know my volume. Using that, can't I calculate the mass I'm going to? Yes, I can do. That's all. So here you can play in your physics. So let's see how it is working. Okay, so this is your trough and it is completely filled with layers of liquid, and the height be h. Okay, I know the density of water. Yes or no? You all know the density of water, that is 1000. So I know the density of water, so let it denote by the alphabet rho. And I know the volume. I'm going to take some 2 liters of volume, some liters of volume I'm going to take. So I know, let it be 1 liter or 2 liter, anything, that doesn't matter here. I know my volume. So now what is my purpose here? Don't forget your purpose always. So my purpose here is to find the pressure. So pressure is nothing but thrust acting in an area. So what is your thrust definition? Your thrust is nothing but the force which is acting in a perpendicular direction. The force which is acting in a perpendicular direction, again by area. So what is your force formula? Newton's law, recollect it. It is mg divided by a. Yes or no? It is mg divided by a. Now you got it. So now what is the next purpose I have to find? I have to find the formula for mass. So using your density formula, density is equal to mass by volume. Now whom I have to calculate? Mass. So bring this volume this side, therefore density into volume is nothing but my mass. So using this I will obtain an equation. Density into volume is nothing but mass. So substitute here density into volume into G divided by A. Density into volume into G divided by A. So this is your pressure formula. So again I can split one quantity here. Which quantity I can split? Think. Again I can split one quantity here. Which quantity? Yes, it is your volume. What is your volume formula? Area into height. So again if you split it, you will get the exact formula which we need. I'll write here. Pressure is equal to thrust by area. Thrust formula is mass into acceleration due to gravity divided by area. Mass formula is density into volume. So whichever formula I'm going to substitute, only that I will change a different color. So next one is I thought I'll use green. Okay, density into. So now for volume I'm going to change area into height into G divided by area. So this is also an area, this is also an area, the same area. I'll cancel this both. Now what is my formula? Density into height into G. So this is my pressure formula. So pressure formula is density into height into G. So I think you all would have understand this derivation of it. So now coming back here, you can find the formula which is written as H rho G. H stands for the height, rho stands for the density, G stands for the acceleration due to gravity. So start memorizing, don't memorize them, I'm sorry. Start to derive this formula by yourself. Assume the condition, recollect the formulas, what and all are used here. So the formula which we obtained is for the pressure inside the liquid. So if it is going to be kept in a particular depth, therefore it will have the pressure plus the atmospheric pressure. So surrounding our earth we have a complete atmosphere that will be exerting pressure on us. So it is a constant factor which we call it as your P naught. Therefore total pressure in a liquid is nothing but atmospheric pressure plus H rho G. So P naught plus H rho G. So as of now we can take this. So total pressure in a liquid at a depth H is nothing but P naught plus H rho G. P naught is your atmospheric pressure. See, you would have studied about atmosphere in your geography. You know the different layers of atmosphere which is surrounding us. So all those layers will be exerting a force. Yes or no? Every one of us are experiencing that atmospheric pressure. Therefore, an object which is kept inside the liquid should also experience that atmospheric pressure. So it's something, a constant which is experienced everywhere. So we cannot exclude it. So we have to include it. Therefore, P naught plus H rho G. The next one is factors affecting the pressure at a point in a liquid. So always remember the formula which you are learning is the factor which is going to affect it. So it is as simple as such. The formula of the pressure in the liquid is the same factor which is going to affect the pressure. So what is the pressure formula we studied just now? It is height, density, acceleration due to gravity. So what happens to the height as I go deeper into deeper? Okay, imagine a person is just drowning inside the sea. So if he goes down and down and down, he feels more pressure on him. Therefore, the pressure increases as the height increases. That is an obvious in nature. If you're going deep into a well, deep into a sea, you cannot breathe. You feel someone is going to got you? Yes or no? So that is one point. The next point is the density of the liquid. More dense it is, the more weight you're going to feel on it. Okay. Next one is your acceleration due to gravity. So as I told you, the formula is going to be the key factor of it. So let's look into it. At the particular place, the Earth's surface, the gravity will change. Yeah, the gravity keeps to change in a particular place. So in the same manner, it will alter. Directly proportional. Next one, directly proportional to the height, as I told you before, directly proportional to the density of your liquid. However, the pressure inside a container does not depend upon the shape and the size of the vessel, and it also does not depend upon the area of the surface in which it acts on, because we are not having any formula here which relates your area. It does not have any formula which relates your area. We are having formula which is going to relate with your height, density of the liquid, and acceleration due to gravity. Okay, so if you're going deeper into a sea, you will feel more pressure. If the liquid is going to become denser, okay, if it is going to become denser and denser, again your pressure increases.